let's start off with the principles of cartography. Cartography is the art, science, and techniques of making maps. So with that said, we've keep repeating this, that maps can lie. Poorly made maps can miscommunicate information. Every map you make is just one of all possible maps you can make with that data. You guys worked with the California data, you saw population, you saw airlines, hospitals, fire stations. That's the way your maps you can make just right there. In addition, complex maps can be difficult to understand. You want to keep things simple for your end user. So when a GIS map is the result of complex analytical or modeling processes, good design is essential for understanding. Keep it simple. Ultimately, the map is what distinguishes GIS as a different approach to the management and analysis of information. That just means you can display the data in a chart, but you could also display it in a map. Let's talk about the design elements of a map. Let me see if I can hide meeting controls. There we go. That's helpful. All right. There are multiple different elements of a map. Who can tell me some of them? The legend, yes. Here's the legend. Not to be useless without a legend. That tells you what each color means or each symbol. What else? What does a map need?
Directions.
Yes. Either a compass rose or a north arrow, which it has here. They're all listed here. So it obviously needs the map and an inset so that you know where the map is located in the world. Actually, this is where the map is located in the world, and that's the inset that's showing you the actual information. Which I have no idea what that is. Oh. So the four main elements that you always have to have are a north arrow, a scale, a legend, and a title. They add some additional things like a grid and the projection and the author's name and the data sources, which are all important things, certainly. But if you don't have a scale, a north arrow, and a legend, people are not having any idea what your map is. So this is a map of biome types. And this is a very, very poor representation with the colors because they are showing you areas in between Australia and India. But they've got the background ocean as one color blue and then like the seas as a different color blue, because they have some marine biomes. And then they also have the islands as the different greens and yellows, which tell you the terrestrial biomes. And that's not exactly, I would not have kept this color blue background because it makes it really confusing. When you look at this, you're like, what is that? Is that a landform? Is that an ocean? That's very confusing. So either making it a color that's the same or even like a gray so it receives this in the background probably would have been better. I'm going to critique every single map that I have examples of in here. Like this one. This is a soils map. This is very busy. So typically these maps will be the size of like a whole wall. A lot easier to read when it's the whole wall, because right now you can't even read what this legend says. Way too much information. The colors merge together, so you don't know if this, the red here is like a pointer, like a this red or one of these reds or one of these reds. Could be anything. But this is what soil maps typically look like, and this really is the best way they found to symbolize that many soils. Yeah, unfortunately, it's awful. It is very hard to put a lot of data on one map. This map is the isolines that show malaria vulnerability. So they kind of clustered things, but instead of doing like a red-green cluster, they chose colors that are not alarming. Sometimes when you see this red-green map and you're in a red area, you're like, oh my God, oh no. You don't want to cause panic. So purple's a nice neutral. Using the ISO lines definitely shows you the separation between high and low risk areas without making it too alarming. So this is one way to do a map that's a gradient. So you see it goes from light purple to dark purple. Typically you'll see the lighter colors be a lower value and the darker colors be a higher value. You can also see that there are different colored symbols, but they are the same shape. So the yellow ones are no data, and the red ones are populated camps. I don't know this area too well. Not quite sure what that means. Then also notice they included graphs, so you can see by month how the malaria vulnerability changes. And you can, I think it looks like August is potentially the highest month in each areas. So maybe you want to stay indoors, wear bug spray, sleep with mosquito netting. I have to tell you a lot of different things. Avoid that high risk area near the coast down there. You can also do population density maps. This is a chloropleth map. You'll notice it's got the scale, the north arrow, has a legend, a title. And this one does, once again, darker value is the higher population and lighter value is the lower population, I think. 7, 19, 32. Nope, they flipped it. Now that's confusing. People aren't used to that. So it's actually yellow is the greater value. Why would they do that? Because not everybody knows how to make a good map. So definitely having a legend is important, or I would never have known. Would have been like, there's a ton of people right here in Alabama. There's like nobody living in the Everglades, except that's like Miami and the highly populated areas.
Why wouldn't they like?
I would have, right?
Because usually you read it from orange.
Mm-hmm. True, true. Yep. So you learn how to do that in your symbology, where you can adjust how you want it. And I think you're probably going to do more of that in lab this week. That's what the chapter's about, although I didn't look at it closely. Super unprepared for this week, guys. You aren't the only one who's struggling keeping up. There's also some really cool maps. This is one that's not rooted in space. It is the politics of Minnesota. So it's more of a metaphorical map. So you have liberal to conservative, and then the percentage of votes that Republicans have. Yeah, it is a little confusing.
I don't even know how to begin.
Right, so as you go further right, it says Republicans become more popular. Republicans are at the top, more conservative, and then Democrats down the bottom, more liberal. So I actually expected Republicans to be a little bit more. So it actually shows that the vote's kind of split. There are less Republican votes by Democrats than there are by Republicans. It's like the median is here, there. So more Republicans voted conservative. They also did it, besides, it's by, they broke it out by city, okay. So Minneapolis was very clustered here. So it voted mostly liberal, not even Republicans voted liberal. And same thing with St. Paul. Duluth was a little more conservative. The rest of the county vote is like this. Twin cities of Rochester, so inner Rochester and outer Rochester, actually were completely split, about half and half, Republican and Democrat. And then there are some outlier islands. So, for example, there are some liberals that voted Republicans that voted liberal from, I actually have no idea what that says. Sunfish Lake. There are some Republicans that voted, there are some super conservative Republicans in Princeburg or something like that. And they gave them cute little names like Mount, I don't know what DFL stands for, but it means something that's Democrat. Gulf of Partisanship. That's like when you either straddle the fence or you can get along with both. So you can have GIS and maps that are metaphors. So this map is Indian lands, and you can notice the green is reservations. And it's really hard to read this too because it's so small. How would you improve it? Yeah, you totally eliminate those holes. I think this is a state right here.
Yeah.
Iowa, thanks. Yep.
It's like, there's nothing there,
Yep.
so you can just like cut off the bottom and just like have it sit
Yep. So instead of it doing it regionally, maybe you do it by state. So you zoom in on just this, zoom in on just this, and then zoom in on just that. Yeah, right. Any other ideas? How about that red symbol? That red symbol says it's trust land. Do you see any of those on the map? Just at the tippy top up there. So maybe you want to zoom in on that, have an inset map of the whole Midwest region down here that says, shows where the zoom in is. That could work.
I was gonna ask, can I like make it like smaller and do one of those like window things?
Yep.
Where, like, show the zoom?
Yes, that would be a great idea, great use of insets. And if that's not in this week's lab, I can show you guys how to do that. They also have symbols for highway, which is the red lines. That's pretty typical. Rivers are blue. That's standard. It looks like interstates are
I don't know. It's a blank box. Maybe it's a white line, but that's terrible because you can't tell what it is. Cities are dots. Okay, yes, that's usual. And they're labeled by the city name. Good. Swamps. No idea why they have blue swamps, but also the outlines of the states are this fuzzy blue, so that's confusing.
Probably shouldn't have done that for a map to scale.
Yes. So, wait, we're gonna get into some even worse ones.
I like critiquing them.
All right. So this is a diagrammatic map. So this goes both directions into, I don't know if it's positive and negative numbers. Usually they're positive. Yeah, okay. So they have positive and negative. Once again, the legend should be flipped because red is negative. So it's showing a loss of housing units in central Pennsylvania, Allegheny County. And an increase on the outskirts. Do you guys know what we call that? Suburban sprawl. Suburban sprawl. So this is a good example of how you can show a positive and negative
Change in one map with two colors.
And it's an example of a choropleth map.
Choropleth maps are color-coded polygon maps, and they show a numeric attribute.
You have in here the top left is pop, soda, or Coke. Yep, these are all pop, soda, or Coke, and it's just showing you the different color schemes. So, assuming that the symbology is standard, darker is higher and lighter is lower. So you have more people calling it pop, yep, in the Northwest region, Midwest, Central Midwest. You have more people calling it soda in New England and California and Florida. You have more people calling it Coke in the South. And then you have people calling it something else in, what state is that? Wyoming and California. What do they call soda in California and Wyoming? And Massachusetts too has other pretty high value of other. Tonic? Okay.
That's the reason.
What do you guys call it? Soda? Anybody not call it soda? Okay. Yeah, I call it soda. But I call it drinking fountain a bubbler from Rhode Island. It's a bubbler.
I mean, yeah. I feel like a lot of like older people, like like grandparents, call them pop.
Yeah, that's true. Yep.
I just it's a water fountain.
Yep. It's totally a regional thing. I was on an interview with someone in the UK and I kept saying wicked and she kept making a face. And I was like, oh, wicked means like very, 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 very.
I was just having that conversation with someone this morning. I was like, I have to wicked, but they're from the Netherlands, so like they don't get like
Yeah, that's a local thing.
saying it like you know what it means.
Yeah.
He thought it literally meant like wicked,
Like evil. That's funny. Oh my goodness. That's cool. So let's do good, bad, bad map with this one.
Oh.
Yeah. Oh wow. Which one's the good map? Well, actually, it tells you. All right. The colorful one's the bad map. The monochromatic one is the good map. But why?
That hurts.
Hurts,
Or
hurts, hurts.
yeah, the right one is a lot.
Yes, the bright one's a lot of colors.
It's not like ordered. Like if you're gonna use those kinds of colors, that it's there means some kind of like
Order.
order,
Yeah.
something
Yeah.
Just to make it like so it's not just jumbled. It
Perfect.
makes no sense.
Right. It makes no sense. It's jumbled. It doesn't go in any sort of order. I love the light to dark on the good map. Definitely tells you the poverty quantiles.
And the leaves.
Yeah, that's terrible. Wicked bad map. All right. Oh, all right. What are your questions? Yeah, okay, cool. How about those of you at home? Any questions? I cannot see the chat box, so if you have questions, please jump in.
No questions.
It's okay. So visualization. So this is a lot of words. The most important thing is this last one. It's the process of representing information so that you can recognize it, communicate it, and interpret the pattern and structure. It started off just being whatever people thought looked best. And then people started scientifically looking into like how many colors the eye can actually see and distinguish. What do you think of patterns in things? Like, are you able to distinguish if there are just multicolored dots? Or does it make more sense if you have a red dot and a blue triangle? Are you able to see things better? So let's talk about how the human eye sees colors. It has a radiometric resolution that ranges between 3 and 4 bits. That means you can only see 16 shades of gray. If you're lucky, if you're colorblind, you might see 4. On the other hand, you're capable of distinguishing about 7 million colors. Yes. So if you're using all the colors of the rainbow, you can distinguish a lot more. But you can't differentiate. It's not just 16 colors of gray. 16 colors of blue, 16 shades of red. Like, you can only differentiate so many. Okay, thanks. So the color wheel is a device that provides guidance in choosing colors. You remember there are opposite colors. There are complementary colors. So you can use opposite colors to differentiate stuff in a map. If you want to do, you also said you can use 3 or 4 equally spaced, like blue, red, yellow. You'll easily be able to distinguish them. If you are doing things that are not chloroplet-based, that are not on like a scale or a ratio, so that's separate. You can use adjacent colors for harmony. If you wanted, if you're doing like, I don't know, the relation of Dunkin' Donuts to population. Maybe you want to pick all like reds and oranges. Separate colors, right? Actually, like it's more right here. So there are 3 different dimensions of color. There's hue, intensity, and saturation. Hue is what we would call like the color. Intensity is what we think of as like the brightness, and the saturation is kind of what we think of as closer to contrast or darkness. If you want to learn more about color theory, I'm sure there are art classes that teach it. The important thing for GIS is that the colors have meaning. You know, politics, what red and blue mean. We know Dunkin' Donuts is a pink and orange. So I can be like, look, I don't have one. You know, Coca-Cola's red.
Did you know that, like, when yellow and red are put together, like, it's supposed to, like,
Make you hungry.
yeah, that's why, like, McDonald's would want to eat breakfast.
Yep, exactly. They have meaning. Yeah. Blue is supposed to be like confidence. That's why you wear blue to an interview. Green is supposed to be calming. So you in a bedroom, greens have like a calming atmosphere. So cool colors in general are calming. They appear smaller, they recede into the background. And warm colors are usually more exciting and they overpower the cool colors. So when you're looking at a map, the red things pop out, especially when they're against a blue or a gray background. Contrast, who does not know what contrast is? Okay. So use lots of contrast for important features. We'll see it on a map in a couple of slides. Actually, right here. So this is a bad map. This, for me, this looks like it's all one color. I know there's 5 different colors, but good luck differentiating between them, especially if they're not next to each other. Who knows if this yellow is the same as this yellow or this one.
Next to the color, like,
Right, you can tell there's like a gradient here, but if you look from here to here, those are 2 different colors.
like, the
You
color
can't
that
tell.
will make it one blue. This is baby called Island Blue, and it's basically they have these blocks,
Mhm.
and originally they have it in like order, like it's all perfect, and then they mix it up.
Ooh, and you have to put it back in
You
order?
have to put it back in order.
Cool.
But the thing about it is like it's all random, so like there could be like a really dark one next to a really light one, but then they could actually be like really close to each other. It's just the colors like when it's around each other,
Right, you can't tell when they're mixed up.
but it's like awesome.
All right, so look what happens when you increase the contrast. When you go from light, dark, 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 dark. You can see the difference is a lot better. You can tell that this is a different color than this. I don't know, whatever I pointed to last time. So use more contrast. Now ArcMap has a whole bunch of different symbology built in that kind of helps you not screw up too bad, unfortunately. So in addition to contrast, you have to think about graphic hierarchy. So you want to put bright colors on your important features. So obviously, what are we focusing on here? The red dots, yes. Right, so you assign the drab colors to things that provide context, like the gray squares. So those are there, so you have like a reference point. So if somebody said, go to the red bus stop, that's on, I don't know, Pearl Street, you'd be like, what? You say, go to the red dot that's outside the science building. You have I have no idea. Spatial awareness of this area is real bad. But you get the idea. So you have context. Oof. Oh, look at this bad map and good map. Yep, it's pretty terrible. So if you're not telling something about the roads, I can pray, put it in the background. This is clearly they're trying to show a map of things to do in your neighborhood. I don't know, homes, let's say homes for sale in your neighborhood, because this is definitely like census blocks or neighborhoods. But right, it's really hard to focus on this one. The purple things definitely disappear because you have a purple background there. Yeah. So you can see how in the good map all of the things that are not important for home sales are lighter. Whereas the things you want to focus on, those dots, are darker. Honestly, I don't know if it's home sales. It actually looks like it could be Nacho Libre and some fists. I don't know what the red one is. So, what are your questions on contrast and colors? That makes sense? Yeah.
Pretty much.
It is. Yes. Let's talk a little bit more about symbolizing points. So, you don't only need to use dots for every point, especially if your map is going to be published in black or white, or you don't know what it's going to be, how it's going to be portrayed. Using different shapes is a good way to ensure that everybody will be able to read it regardless. Someone's colorblind and they don't see the difference between red and blue, which I don't know what's one. But you wouldn't want to do blue and green and then have someone be colorblind and say, I can't tell the difference between these squares. Use a circle and a square. And that they've done tests. They did scientific experiments where they brought people in and showed them maps and they could read it better when the symbology was different. They used different points, different shapes for your point. You can also do graduated points. So this one's crime account by address. The more crime there is, the bigger the circle. What town is this? There's that much crime. Right? Is this the same town as the previous one? It is. Bedford Ave, drugs, burglaries. So cool. Yeah. Wow. So you can use graduated point markers to tell the difference in count data. You can also, you notice when you were doing the airline lab that there are airplane symbols. Oh, it is Nacho Libre. That first one, it was burglaries with the masks. It definitely wasn't on sales. So the point markers are only good for large scale maps. You saw when you had all of California on your screen and you put the airplane symbols, it like took over. If you had zoomed in, it obviously would have made more sense to use something like that. So when you're zoomed in, or you're using a large scale, you can use some cool, funky markers. When you're zoomed out, like a whole state or region view, you're probably better just using little dots or graduated dots. Or, yeah. So one thing about graduated dots, so you've seen the John Hopkins map of coronavirus, I'm sure, where New York City, the amount of cases in New York City then started to overlap with the rest of the New England states. You would not want to use graduated points at that level. It would be better to do like a chloropleth by county or town, depending on what your data looks like. So do not do size graduated points if it starts to overlap, because you lose the background data. All right, let's talk about lines now. Most lines are usually graphed features, so they should be light. So this one, is it a good map or a bad map? Bad map. Unless you want to know what I think those are probably boroughs in New York. If you want to know where the boundaries are, sure, that's a good map. However, I don't think that's what they're trying to tell us. So you want to make those gray and make them recede into the background. You can also use dashed lines for less important features. And there are some industry standards. When you're in the symbology, this is an old picture, holy moly. Here's some as a sidebar. And you'll see there are things for different road types. There's railroads, there's interstates. use industry standards. So we're going to talk about polygons, but I'm also going to talk about the lines first. So if you didn't want to know where that borrow was, you'd want it to receive as the background. So do not outline boundaries of most polygons. Now, so far you've done a lot of larger scale things. California, of course you want to put the boundaries of California. Yes, that makes sense. But if you are looking for, I don't know, if you wanted to show what the parks are, making everything else go into the background is really important. You don't want to compete. You don't want to compete by doing borders around features that are less important. Even the borders around the parks, I get rid of because it just didn't draw your eyes what they wanted you to. Oh, okay. So what are your questions? Okay, I have a question for you guys. When you are creating a map, what you should you be thinking about?
What kind of, like, why are you making that?
Why are you making a map? What features are important?
How to show.
How to show the important features. Yep.
Gonna see that.
Who's gonna see the map? The audience? Yeah. Because so the average American has like a high school grade level or below. You are not gonna want to make a map that is super duper complex that only like a grad student can understand. You're going to want to make one that my freshman can understand, right? A lot of times I'll actually bring her in when I'm making a map. I'll bring her in and I'll say, hey, tell me what you think this map's about. And if she gets it completely wrong, I know I did a bad job. Which she has before. She's coming in and she's like, Mom, I have no idea. It's like penguins? And I'm like, oh no, okay.
Time to restart.
Yeah, exactly. I'm like, definitely have to rethink this one. So. All right, so there's a bunch of different ways to visualize. We're gonna go over a bunch of 2D types of maps and then talk about some 3D. 3D is the future and it's freaking awesome and I love it. I'm gonna spend a whole week on it at the end of the semester if we get to it. I might drop some things in between just so we can get to the 3D stuff because it's so much cooler. Okay, so there's reference maps. They reference things. What? Reference maps? So it helps you locate things like towns and states. They're supposed to be highly accurate. You would use an equal area projection because you want to see things represented equally. Right, and they're used for like land use and zoning and tax purposes. They're just used for reference. Oh my goodness, there's more on the slide. Political maps, military maps, infrastructure maps, they're all reference types of maps. Okay, then you have thematic maps. Okay. So thematic maps are about a specific theme. This one's injury mortality per 100,000 people in the population in 2008. So they're more concerned about how things are distributed in space. You see the order values, and it helps you compare like the US to Russia, for example, where there's a lot more deaths due to injury. So reference and thematic maps are not mutually exclusive. You can actually use them in conjunction with one another. There's also dynamic maps. Yay, welcome to the future. They're interactive. You use them probably every single day. Waze, Google Maps, Pokemon Go is even a dynamic map of a different sort. Yep, so they're interactive. There are some really cool dynamic maps that if, I'm not sure if the Boston Marathon uses it, but they'll give you a tag where you can watch a runner and see where they are in a race, which is cool. Lots of other dynamic maps. Think of like airline flights, those are dynamic maps. Hell, even the stuff in space map that we looked at. It's a dynamic map, even though it's the atmosphere. All right, modern mapping. This is like the best part. This is a digital terrain model of the ocean. Why? Okay, so you remember how we talked about how the Earth is a lumpy space potato? There's this crazy high point right off the coast of Japan. You see the white blob there? And this really shows it. So why is there a mound of water along the western equatorial Pacific? Next to Japan. Anybody have an idea? What was the question? Why is there a mound of water there next to Japan? A fault. There is a fault line there, yes. The ring of fire. Yep. I don't know if that's why the sea level is higher there, but a good hypothesis. I don't think I've ever found out the answer to that question. I know, that's what I was just thinking. Let's Google it. Convergent equatorial flow and surface winds. So it's from the ocean and air circulation. The Polaris effect is actually air. So, yeah, cool. Now we know. Now I'll know next time. I found the meeting controls. I'll hide them again. Go back. Okay, so most mapping today is done by computers. You've been doing it on computers. You've been talking about triangulation and how with GPS satellites, you need 3 to get your location, and that 4th one gives you the elevation. So the X and Y is like your latitude and longitude, and then that Z is your elevation. It's the point on the surface of the Earth. So that allows you to do things like sea level height. It allows you to do mountains. That's how we create new contour maps now. They used to go out and use, have you ever seen surveyors like on the side of the road using a tripod with a camera? So they're looking at heights in street level, so that if they were doing construction, they know how the heights differ from one side to the other. They used to do that to make contour maps. So old school contour maps of like Wachusett Mountain, they went out with surveying equipment and they measured all the different elevation changes. Just like crazy. That's so much work. Also soil surveys, they used to go out and survey soils back in the 60s by hand. And they have the whole United States done. It's crazy. That was one of those first maps we looked at, the soil map. They went out there and they determined each of those soils by hand. There are soil science classes. I'm not sure if Pittsburgh has them, but I know UMass does, and I'm sure other universities do. You can always do a semester at another school, or even just a course at another school. It gets tricky if you're doing like financial aid and stuff, but it's possible. Where one school pays the other. It's kind of like a exchange, but instead of doing international exchange, it's just like intersystem exchange.
My favorite thing is like I always wanted to be a character. And I'd be the only out of the 4 kids who were there to help. I was the only one that would actually like get down and like actually get ready. Like I would really believe that on the ground. And my older brother was like, I'm gonna blow the grass. And then that's how we did.
Nice. So what classes should she take at Fitchburg that allow her a lot of field work? Favorite person too? Chris, Dan, field work classes?
There's a geography class.
Geography. Geology. Take geology. That's Reed, I think teaches that. Reed Parsons. Yeah, he's great. He wants to map all the boulders on campus. So you connect with him, somebody connect with him and start a project. Get it published. On boulders on campus. Take geology, you'll go out in the field. So, Chris, any field work courses you can think of?
But
Okay. Yeah. Oh, I love getting out in the field. I was blessed. I went to Brigham Young as an undergrad, and all of their science classes, they go out into the fields. So I got to study the forestry, the wetlands. We didn't do much with soils, unfortunately. Macrovertebrates. So you go out to a stream, and you have a net, and you kick around, and you catch all the little buggies in the net, and bring back and look at them under a microscope and ID them. So cool.
We did that at my high school. We there was like a stream in the back of the high school, so we put like bags, like conference there.
Yeah.
We left them for like a week or two, and then we came back. Yeah, it's cool fun.
Yeah. All right. So conclusions. Cartography is both an art and science. We went a lot into the art of it. There are whole classes dedicated to teaching about cartography. I took one. It was awesome. Talk about an easy A. Oh my God. If you like design, take cartography. Maps are clearly fundamental to GIS projects. Usually your result will be a map. Or will include maps. In my case, I do a lot of statistical analysis. So I'll have like 6 maps of the data, but then like actual outputs of like a final table usually that tells the details of what it means. It sucks. It's a lot of me looking at computer code and going, why aren't you working? And sometimes it's because like so R, which is what I use for statistics, updated recently, but a lot of the packages that you have to use for the underlying statistics didn't also update. So it's like version issues, like just watch your work. Yeah, that's what most of my day is. Where were we? Modern advances make it easy to produce good and bad maps. You guys have been playing with the art map. I should make an assignment that you have to make a bad map. Well, in cartography, I'm sure when I took it, they had you make a map and then taught you all about cartography, and then you had to improve that map. My first map was terrible. Mostly because I couldn't get ArcMap to run on my computer, so I made that in R, which is not good for mapping. And then when I improved it, the professor was like, oh my God, you're incredible. And I was like, wow, I kind of had an idea you were going to do this. So